Now let's look at question 6 of the same question paper, November 2018. Question 6, we are given f of x, which is negative into x minus 3 squared plus 25, of which you should be able to see that this is completing the square form in which we have been given f of x. That is, f of x is equal to a into x plus b squared plus q. And we are given g of x, which is equal to 2 into half to the power x plus 1 minus 4, of which on this one you can see that a is greater than 0 and b is greater than 0 but less than 1. That means the graph is above the asymptote, of which the asymptote is y is equal to negative 4. So it's just brainstorming before you really attack the questions. Now let's go on to the questions. 6.1. Write down the equation of the asymptote of g. Now g is here, we have already indicated the asymptote, that is y is equal to negative 4. 6.2, write down the coordinates of d. The coordinates of d, if you check on the question, we are talking about the turning point of f of x. So 6.2, we know that we should be able to read the coordinates of the turning point if we are given the function in this form. So the turning point is simply 3, 25. These are more free marks, just to welcome you into the question. 6.3, you are asked to find the range of f. You are asked to find the range of f. That is, we notice that our graph f is like this, and the range, we are talking about the values of y, and we know the maximum value of y is 25, so we are simply saying values of y are less or equal to 25. If you decide to write it in this way, if you decide to write in another notation, y is an element that is from negative infinity to 25, and 25 is included. 6.4, we are asking to calculate the length of EB, and looking at the graph, we notice that our graph is like something like this. So this is B and this is E. So these 2 points are on the y-axis. That means for us to find the length of EB, that is, we just need the y coordinate here and the y coordinate here. So EB will be equal to y coordinate at E minus y coordinate at B. So these are the intercepts of the 2 graphs. That means we need to find the intercepts. So let's find y at E. Y at E we'll get it when y at E, we'll get it when x is 0. So just say substitution, negative into 0 minus 3 squared plus 25. That will be minus 3 squared is 9, 9 by negative is negative 9 plus 25, that will be 16. And then y at B, we'll get by putting 0 on g of x there. So it's g of 0 which is 2 by 2 by half to the power 0 plus 1 minus 4. So this will be 2 by half minus 4, which will give us negative 3. So basically we are saying EB is y at E, that is 16, minus 3, and that will give us 19 units. 6.5, determine the values of x for which f is decreasing. Now if we look at the graph of f, we can see it's concave down. That means it's increasing from left until the turning point, and then after the turning point it starts to decrease. And we know that the x value at the turning point is 3. So for values of 3 of x that are greater than 3, f of x will be decreasing. So 6.5, we are saying f is decreasing for values of x that are greater than 3. And remember that when x is 3, the gradient here at the turning point is neither increasing nor decreasing. So it will start to decrease after 3. So that's why we are saying it's strictly greater than 3. Now 6.6, calculate the average gradient between A and B. If we check our graph, we will notice that A is this point where the two graphs intersect, and it's also the x-intercept of both graphs. And B, we have already found the coordinates of B. We know that y is 3 there. So all what we need is to find the coordinates of A. So you may decide to use f of x, you may decide to use g of x. Whichever you will use, you should be able to get the same answer. Let's use g of x to find the x coordinate there. So we are saying g of x will be 0, that is the x-intercept. So 0 is equal to 2 to the power half, the power x plus 1 minus 4. So we can bring the 4 this side, that is 4 is equal to 2 by half to the power x plus 1. Then we divide by 2, so 2 will be equal to half to the power x plus 1. And then let's make the base the same. We know that 1 over 2, we can write it as 2 to the power negative 1. So we are basically saying 2 is equal to the power negative 1 raised to the power x plus 1. And then laws of exponent tells us that we must multiply these exponents. That is 2 is equal to 2 to the power negative x minus 1. Then the bases are the same. We can equate. We know the exponent for 2 is 1. So we can now equate the exponent because the bases are the same. So therefore, allow me to move to this space. 1 is equal to negative x minus 1. Take the negative x to this side, and then the 1, so it will give us negative 2. So we are basically saying here, x is negative 2 at this point. So the coordinates of A, we know now it's negative 2, 0. So now we can go on to find the average gradient between point A and point B. So therefore, average gradient will be equal to y at A minus y at B divided by x at A minus x at B. If you happen to make a mistake and put x coordinates on top and y coordinates at the bottom, that is not acceptable at all. It's a breakdown, you will lose marks there. So our y at A is 0. Remember, just to write the coordinates. A, we say it's negative 2, 0. B, it's 0, negative 3. So y at A, that's negative 2 minus y at A, it's 0. I almost made a mistake, which I've just reviewed. 0 minus 3 divided by x at A is negative 2 minus 0. So this will give us 3 over negative 2, which we can write as negative 3 over 2. That's the gradient. Then moving on to 6.7. 6.7, graph T is obtained by reflecting G about the x-axis. Write down the range of T. Now we may need to understand transformation of graphs. If we reflect g of x along the x-axis, that would mean this part of the graph will be coming down. That's the reflection of this part. And this part will be, and then our asymptote will be there. So if the asymptote is y is equal to negative 4, if it's reflected along the x-axis, it will come to positive 4. So we are simply saying the graph of T will be, for the values of y for the graph of T, y will be less than 4. That's, we can basically read that, or we can as well waste time by saying T of x. If we reflect along the x-axis, it means we are multiplying f of x by negative. So that will be negative into this is g of x that is reflected. So it's negative into g of x, that is 2 into half to the power x plus 1 minus 4. So removing these brackets is negative 2 into half x to the power x plus 1 plus 4. And that now gives us the new asymptote, that is y is equal to 4. And also looking at A is less than 0 and B is greater than 0 but less than 1. So this shows that the graph is under the asymptote. The asymptote is there. The graph is under the asymptote, which will be in this form. So we can be able to tell now that the values of y are less than 4 because the graph is below the asymptote. All right, let's move on to 6.8. 6.8, if p of x is equal to f of x plus 2, write down the coordinates of the 10 point of P. Now, P of x is coming as a result of f of x being shifted up by 2 units. So this is a vertical shift. A vertical shift does not affect the x coordinates, but it only affects the y coordinate. So we know that for f of x, the turning point is 325. So for P of x, if we are moving f of x 2 units up, the turning point, x will not change because it's a vertical shift, but the y coordinate will be moved up by 2 units, so it will be 25 plus 2. That will give us 327. Then the last question, 6.9. 6.9, determine the value of k for which the straight line y is equal to 2x plus k will be a tangent of f. Now this question becomes very tricky under exam condition if you have not accustomed yourself to solving questions like this. That's where people just leave the space and they don't know what to write. But then what we are saying here is that we can notice that the straight line is having a positive gradient. That means if it's a tangent, also it's basically on this side of f. And if it is a tangent, it has one contact point. So at this contact point, it means that our y is equal to 2x plus k will be equal to f of x. So we are basically saying negative into x minus 3 squared plus 25 will be equal to 2x plus k at this point. Now, let's try to simplify this. Negative into, if we expand the bracket, that's x squared minus 6x plus 9 plus 25 is equal to 2x plus k. And then removing these brackets is negative x squared plus 6x minus 9 plus 25 is equal to 2x plus k. We can take this x squared, everything to the right, so that we just don't work with this negative. So we'll be having x squared, the positive 6x becomes negative, that is 2x minus 6x, that is minus 4x. And then 9 minus 9 plus 25, that gives us 16. If we transpose it, it becomes negative 16 plus k is equal to 0. So this is the equation that we are having. And please just check if everything is correct before you proceed, because you might waste time. All right, now, one thing that you have learned that is also applicable here. If a quadratic graph and a line meet at one point, it means we have two equal solutions there. Remember, if a graph is having a turning point on the x-axis, when you solve this quadratic equation, it will give you two equal values or two equal solutions. So now, we translate that to the nature of roots. we know that if we have equal roots, the discriminant or delta will be equal to 0. So that's how we are going to formulate an equation for which we are going to find k. So we are saying b squared minus 4ac should be equal to 0 if we are going to have one solution there. So our b is negative 4 minus 4 by a, which is 1, and our c is minus 16 plus k. This should be equal to 0. So if we square here, we get 16, and then minus 4 by 16, that's a positive 64, and then minus 4 by k, that is minus 4k, is equal to 0. So 16 plus, that would be 80 minus 4k is equal to 0. You can take 4k to the right, that is 80 is equal to 4k. Therefore, we divide by 4 both sides, that will be 20 is equal to k. So the value of k in this case is 20. So it's those are the intricate moves and logical thinking, critical thinking that you gain from attempting and practicing questions like this. That's only when you will be able to connect the dots and reason from one end to another. Because in this question, remember, we expect a question on roots to come mainly or usually as question 1 in the paper. But then it is also coming here and you need to apply that to solve a problem. I hope this assists you in your efforts to try to prepare for the final examination. Let's meet as we continue to revise.